Hi, I'm Mike Stanzik and this is Digital Electronics Classroom. In this video we're going to introduce the term voltage and what it means for circuit basics. So I don't think there's much I have to say in the beginning here, so let's just get started. Voltage, it's kind of a fun word. It's measured in volts. So there it is. What do we want to think about voltage? I like to compare it to energy. It's the amount of energy per coulomb of charge. So it's energy per charge. Oops, let's make that an R. Okay, energy per charge. So when we're looking at a circuit and we have a power source or a battery, right, and then the circuit goes through a couple of elements here, something like this perhaps, okay. The charges, as they go through the circuit, they gain energy and then they lose some energy. Sometimes we kind of do this with some coloring here, so I'm just going to kind of color these wires, and let's just put this one to be green here. Okay, so basically what's happening here is that at each of these different wires, the charges have different amounts of energy. And it's sort of like kind of a ball that's rolling down the hill. And so we have a hill, and then it gets a little bit lower, and then it gets a little bit lower towards the bottom here. And then there's sort of like a stairway or a ladder that gets you back up the hill as you kind of come around, okay? So if you think about a ball that has a higher height, and then it rolls down to a lower height, and then it rolls down to an even lower height, then we take that ball around and then we raise it up the ladder again. That's kind of what's happening in this circuit here. So the battery, its function is sort of like the ladder. So it brings a low energy charge to a high energy charge, and then those high energy charges across from these resistors elements, these resistor elements are like the hills. And so you're going to change energy by going through this resistor element. You're going to change from high energy towards a low energy. And so if I were going to kind of mark these up, you know, this would be sort of where the red is, and then this one would be where the green is, and then this one down here would be where the blue is, and then this whole area would be blue. Okay, so we rise up to a higher level, and then we go through an energy transition as we go through each of these resistors. Okay, so that's sort of the analog in a physical sense of what's happening in the electrical sense right here. So voltage is that measure of how much energy you have. So that red voltage here, that green voltage there, the blue voltage there, and as it goes around the circuit, these charges as they move lose their energy as they move through the circuit. So we kind of think of charges as these little bits of things that are moving through the circuit. And so when these little bits of things move across here, they become lower energy. And so what happened to that energy that they lost? So if they lost some energy during that, just like you lose some height here, what happens in between? Well, in the case of the rolling down the hill, we see that energy transform into motion. So as it rolls down the hill, it gets faster, right? And so we know that. Well, do the electrons here get faster? Sorry, the charges here get faster? Well, not necessarily. And so instead we say that that energy is delivered to the actual element. And so the energy is delivered to the resistor. Okay, so whatever amount of voltage difference there is here is the amount of energy that's delivered. Okay, so we don't care about an absolute height in terms of what's going to happen. We care about the difference between the two heights to see what's going to happen to the ball. Because what if we had this situation and I said, hey, guess what? There's an even higher part of the hill up here, right? Would that ball roll up that hill? No, it wouldn't, right? But it would roll down to the green. And so we don't care that the ball is at red right here. We care what the difference is between this red and this green. And so since there's a difference between the red and the green that's a lower energy, then the ball will roll down the hill. The same thing that happens here in terms of the charges. Since the red is high energy, and then the green is lower energy, then it will roll down the hill. The charges will roll down the hill and go around the circuit in this clockwise fashion. And you notice as we go around, we keep getting lower and lower energy until we get to the battery. Just like in this example, the ball goes to lower and lower heights until we get back up to the ladder. So the only things that are adding energy to the circuit are the batteries or the power sources, the ladders of the circuit, if you will. And that's the idea of what we call voltage. So let's take a look at this in more of a circuit solution context. So if I have a situation that looks like this, and so say again we had sort of a red energy level over here, and then we can call this maybe this part of the circuit A, that wire part, and so we might say that this has a voltage VA. And then on this side perhaps we have a green level of energy per charge, and then we can call that B, and we might call this VB. Then we have this resistor in between, and I'm going to just call this resistor element 1. And so a lot of times when we talk about voltage, we'll give this also a value V1 to say that's the voltage. This is called a branch voltage, or an element voltage. It's a difference across an element. Okay, and I'll explain what that means, because V1 is going to be the difference between the voltages on the other side. So it's going to be VA minus, oh, look at me use the colors. So proud of myself, VB. Okay, something like that. So what we're saying here is that this voltage isn't actually just a one voltage value, it's actually the combination of the difference of these two voltages. It's the difference. So we care about the difference between VA and VB because that's the change in energy that a charge will experience as it transits that element from one side to the other. Furthermore, high voltage pushes to or toward the lower voltage. So that's the direction of the charge flow. And so we have a direction of flow from the left to the right in this example because we have higher voltage over here and lower voltage over there. Okay, and so that is the expression that we're going to use when we talk about a branch voltage. These other voltages, VA and VB here, these are called node voltages. And we'll get more into that later, but all you just got to kind of remember is that they belong to the wire that's on the other side, on the sides of the elements. So you either have an element or you have a node. And so the node is sort of like the wires and the connections over here, and they'll have a voltage. And then there's a wire and connections over here, they'll have a voltage. But when we talk about V1, we're talking about the difference between VA and VB. So a difference in those node voltages gives us what that voltage V1 is. Okay. We also know that V1, since it is the difference between A and B, it's a measure of how much energy is delivered to the resistor. Okay, so it's energy per coulomb. So if 1 coulomb comes through, then we have V1 energy that's delivered to that resistor, and that's how it goes. So that's the basics of voltage. At this point, that's all I want to talk about, and we'll get further into this as we look at circuit basics in the upcoming videos. So I hope you enjoyed, hope that had value for you, and as always, please like and subscribe to the channel. My name is Mike Stanczyk, this is Digital Electronics Classroom, and have a wonderful day.